it's a quick update from our end today. We also have Steb in the call. So I think this is one of the first ones that he's joining, so he can kind of like complement what I say here as well with more depth. But yeah, basically the main update here is that we're going live with FVM M1 on Tuesday. So look out for that. The Skyr Upgrade is coming. We're very excited about that. This basically installs the FVM technology to the network without still enabling user programmability. That's coming with M2.1. We are focusing on EVM programmability first. This is basically, there was recurrent feedback that we kept getting at conferences and events that there's a massive set of developers that are very familiar with the Ethereum development tools and so on that want to start hacking for Filecoin and start building for Filecoin. So they were basically asking for EVM support right at the bat. That's why we decided to focus on this as a first priority. And the other reason is also that native programmability, besides from the technical side inside the FVM, it might seem a little bit simpler to implement, given that we don't have to like cover for an entire new runtime at first. But then in terms of providing the development experience that developers have come to expect, that requires a ton more tooling, libraries, and sandboxes, and client libraries and SDKs that we are able to deliver quickly. So what we want to do is have these threads of tooling, the creation of tooling that is eventually going to support the native development experience, run in parallel with the delivery of EVM to the network. So this gives us a little bit more time to nail the tooling experience for native developers, while we still deliver programmability on the Filecoin network. So this is the main strategic reason that we're focusing on EVM for 2.1. We still need to update this on the website. So the roadmap still reads as if 2.1 was native programmability. So just bear with us there. And now in terms of technical updates, there's tons of design discussions going across the board right now. So if you subscribe to FVM specs, and if you subscribe as well to the FIPS repo, you'll see a ton of those. A few key discussions that I wanted to highlight today is the account abstraction. So account abstraction is the ability for actors on chain to validate transactions. So this means currently the protocol is validating transactions, which means that it is hard to support EVM native, Ethereum native transactions right out of the box unless we add support at the core protocol level. The problem with this is that it basically marries, it couples Ethereum and Filecoin at a very deep level, and the transaction model on Ethereum is going to keep evolving. The transaction model on Filecoin is going to keep evolving, and having that coupling at such a low level is going to be a nuisance going forward forever. So the idea here is to adopt the concept of account abstraction, which is any actor, for the first version, it would be Ethereum actors, would be able to validate transactions and then act as the ultimate senders of the message onwards. So the way that this is going to look to validate native transactions, native Ethereum transactions, is there is going to be a new actor on chain. We still have to figure out the right name. For now, we're using a placeholder called E-account, which is Ethereum-compatible accounts. Any SecB 256K1 account, so this is an F1 address in Filecoin, will be able to upgrade to an E-account. And in order to support this upgrade, we're also introducing a feature that we had talked about, but we plan on delivering later. But for this particular pathway, is we need to deliver this feature to support this specific pathway, and that is basically the ability for an actor to become another actor. So this is for an actor to update the code CID that's backing it. So this is a very unique feature that the Filecoin protocol allows us to do, because there's just this decoupling between actors and the code behind actors. So an actor could decide to change the code CID that's backing it. Of course, the flow here is going to be very interesting because when an actor calls a syscall to become another actor, it is going to supply a code CID, and that code CID, that code will have, in order to support upgrades to it or updates to it, will have a new entry point at the WASM level. So this is a new WASM exported function, which is basically going to act as the intake function. And this function will evaluate if that operation is allowed, and it will perform any state migration that might be necessary. So you can imagine in the future, and this is like way in the future, this mechanism also be used for upgrading even some built-in actors on chain, right? There is a trade-off there. Like we know that, for example, Lee, who's a client implementer here, right? What the migration process looks like in network upgrades, right? So it's like basically you dive into, in many cases, you dive into the state of specific actor types, and you migrate the state object to a new object. So imagine putting this logic in the code of the destination actor, right? This is what the entry point will be able to do. So eventually, when you put these pieces together, this means that a MetaMask wallet would be able to issue an Ethereum transaction. So nothing Filecoin specific, is just an Ethereum transaction that the Filecoin network will be able to accept, because the thing that's validating that Ethereum transaction would be the actor that's backing the sender account. So the FVM will have the smarts to realize, oh, this actor is not supposed to be sent. This transaction is being sent with a type that does not contain a Filecoin signature. It is an opaque blob to the protocol, and it's marked as a transaction that needs to be, so the transaction type that's used here, or the message type, the signature type that's used here, is no signature. So this is basically a sender delegated signature. So now it's up to so the FVM is going to have the smarts to call this validation entry point in the sender actor, so that the sender can then evaluate if the message is correct. And the sender, in this case, if it's a knee account, would be validating the Ethereum signature, and then deciding to continue the processing of that message. If the Ethereum signature is invalid, then it would just error out, and the message would be rejected by the network. So that's basically one of the main developments here. We're also working on a set of other designs that you might want to peek into. Things like, for example, how we're going to support Ethereum logs. So the Filecoin network doesn't currently have support for logs in the style of Ethereum, in the sense that there's a Bloom filter at a block level that is serving as a quick data structure, as a data structure to quickly evaluate if a particular event of interest might be present in the execution of this block. And it also doesn't have support for outputting logs or other transaction execution metadata to receipts. So these are the two things that kind of like Ethereum does when it comes to logs. We want to go further than that. We want to introduce, like, the main design direction here is introducing the concept of execution artifacts. So not just logs. In the future, when we introduce things like, for example, the synchronous programming and callbacks, and maybe user-supplied cron entries and event subscriptions and so on, the execution of those things could end up outputting things like callback IDs and things like callback jobs and stuff like that, right? So these are artifacts from execution. This is a very early idea, but the point here is one requirement here is and the thing that we're thinking through these days is how can we provide the right patterns of access for light clients on the Filecoin network as well. So one thing that we want to be able to provide is the ability for a light client to trustlessly be able to query the network for a particular set of logs that have been emitted, maybe by an actor at a given height, or sorry, there's some background noise. I think it's All right, I know. Thanks. So to be able to query for logs that have been emitted by an actor, logs that belong to a particular topic that have some particular data, and these things should be a node should be able to have a data structure. Like the chain should be having a set of data structures that allows a node to produce a Merkle inclusion proof or an inclusion proof of some kind to prove to the light clients that a particular set of logs is included in a block. So right now, so like these are the things that we're thinking through. And this is kind of like a very, very loose brainstorm of some of those things. So feel free to go into the into the FVM specs repo, subscribe to that, look at the design discussions, also the FIP discussions that are happening, and feel free to contribute. But that's what we are right now. And I don't know if Steb has something else that he wants to add to the technical update.
Yeah, that's the big thing we're focusing on right now. We're also trying to think through like the final versions of things like the create syscalls and some changes to IPLD. They have at least will get punted out to M2.2. But one thing that's on my mind is like the various constraints and counterfactors you might want to prove with create when you create actor address and stuff like that. So really, honestly, 90% of our work is around like actor addressing and creation logic and trying to figure out how to make that work.
Yeah, and we also open sourced the FBM Ebm Prototype. So this is the prototype of the EVM runtime on the FVM. This is currently using a early design iteration, which includes a bridge actor and a bunch of other things that are probably going to go away. There's like we've gone through several simplification rounds, and we've determined that the bridge actor in this particular manifestation can probably go away, and it could be turned potentially into a lightweight registry actor that is mapping addresses. We're trying to figure out some ways to get even rid of that potential registry actor if we can reconcile addresses at a more elemental level. But that's basically what we're working on. We're kind of like doing like a two-way engineering process here, where we are designing specs and at the same time we're prototyping certain key problems that we know still have some unknowns behind them, so that we can meet in the middle and like have this feedback cycle between implementation and design.